Okay, we now do question 8. For question 8, there are two methods of solving the problem. The first method is longer but uh, can be applied to more problems in general, whereas the second method is shorter but it's not so universal. So we start with the first method. Right, we focus on the forces acting on point Q. Even though the system consists of three strings with a weight, our focus is on the forces acting on point Q. Right, so we draw a separate free body diagram that identify the forces acting on point Q. So I call the force exerted by a string QR, right, as T1, and I call the force exerted by PQ as T2, and I label the force exerted by the weight S as W. Right. So we notice that the system is in equilibrium, so that means that the net force along any direction is 0, so the net force along the vertical direction is 0, right? So two forces have vertical components T1, and the vertical component of T1 is T sine 30, and of course the second vertical force is W. So these two forces will cancel each other out. So from that we get the first equation. Right, then we consider the forces acting along the horizontal direction. So net horizontal force is 0. So you notice that both T1 and T2 have got horizontal components, whereas W is a purely vertical force and therefore has no horizontal component. Therefore, we resolve these two forces, T1 cosine 30 towards the right, and T2, which is purely horizontal, towards the left. So that's why there's a negative sign here. Okay, so from that we get our second equation. So we have two simultaneous equations. Our aim is to find T2, the tension in string PQ. So we get rid of T1 by a division, right? So equation 1 divided by equation 2, we get this. T1 cancels and get tangent 30 degrees is W upon T2. We're trying to find T2, so we just rearrange this equation and we get an answer for the tension in the string as W over tangent 30 degrees. Okay, now we go on to the method. As I mentioned just now, the second method is shorter but cannot be applied in general to more complicated problems. Right, so we start again. The forces acting on Q are T1, T2, and W. Right, since these three forces acting on a point Q are in equilibrium with one another, the resultant of these forces must be a zero vector, right? Which means that these forces will form a closed polygon, in this case a triangle, when a vector diagram is drawn, which is shown here. So we just draw the three forces T1, W, and T2, joining them head to tail, head to tail, head to tail, and we get this closed polygon because the resultant of these three vectors is a zero vector, which means that the vectors will eventually point back to the starting position. Okay, so again our aim is to find T2 in terms of W, so we can see that they are related simply by a tangent 30 degrees. Okay, so once again we get the answer for T2, but this time in a much faster, shorter time. That's it.